Hello, everybody, and welcome to our webinar series here at CalCom Software. My name is Roy Ludmir, co-founder and director of business development here at CalCom. Today's webinar will deal with the topic of configuration drift and how misconfiguration undermines security even on fully patched systems. So welcome to our webinar and hope it's going to be a good one. Our agenda today will discuss the topic of configuration hardening and configuration drifts. So first of all, how configuration vulnerabilities are interacting with regular vulnerabilities, or what we call CVEs. What is the difference between a configuration vulnerability and a patch or a software vulnerability? Why they are dangerous? What is the risk associated with configuration vulnerabilities, both in the short term and midterm? And we'll connect it to both cyber risks and compliance risks. This is our agenda. And let's start and discuss the topic of configuration vulnerabilities. What are they? We need to look into the more broader topic of vulnerabilities. And we can divide vulnerabilities regardless if they are at the cloud level, operating system, infrastructure level, but we can divide it into two different groups or types of vulnerabilities. The first one that we are all familiar with are the software level vulnerabilities. Those are exploits that are lying at the level of the code itself, at the source code of an application or a compute environment. And these type of vulnerabilities can just be patched. So for example, if Microsoft is issuing every other Tuesday a set of patches or hotfixes that are based on exploits and code level configuration, or so code level vulnerabilities. On the other hand, we have the less known type of vulnerabilities, and those are the configuration ones. Now, the configuration level vulnerabilities might be associated with a CVE, or on the other hand, it's just a known flow or an integral process or part of the operating system that by configuring it, or when it is not securely configured, it can serve as an attack vector. Now, both code level vulnerabilities or patches and CVEs and configuration vulnerabilities can be found in a different type of database vulnerabilities, and we have few of them. So if you look into more of the government level, we can find the NIST NVD, the National Vulnerability Database, or the known exploits and vulnerabilities cataloged by CISA. On the other hand, we can look into more of the vendor type of database vulnerabilities, for example, Microsoft's one or other vendors. And we have the more, I would call it, industry-based type of database vulnerabilities, for example, the CWE, which is provided by Mitri. So as we said, configuration vulnerabilities are different from code level vulnerabilities or CVEs, though in some cases they might be connected one to another, which means a vulnerability might be patched for a short-term solution, or on the other hand, could be completely configured in a different way, like disabled, or the component can be removed. And this way we are eliminating the same vulnerability, but from the configuration level. The main difference between the two is that software vulnerabilities can be patched as long as there is an available patch. On the other hand, configuration vulnerabilities cannot be patched. It's not just a patch that you distribute to the system. In this case, you need to find a way how to either configure the component in a different way or completely remove or eliminate it. No hotfixes and no upgrades can remove the configuration vulnerabilities. So we've discussed configuration vulnerabilities, but what is configuration drift? So to understand configuration drift, we first need to understand that a configuration setting, can be configured to be secured or not secured. It's not necessarily a binary. It might be 3 or 5 different options, but we have secured levels of configurations and insecured ones. How is it defined? How can we know what a setting should be configured to be secured. Those are usually provided, or the guidance is provided in secured configuration baselines, such as industry best practices provided, for example, by CIS guidelines or benchmarks. On the other hand, DSS that there is another known configuration baseline. And IT or security teams are expected to implement secure configuration. So what is a drift? Let's assume that an organization is implementing a secured configuration. The drift actually happens when someone or something is removing or changing the configuration from being secured to being not secured. Okay, and configuration drifts can happen first over time, but due to three main reasons. The first one are just people, privileged users who are logging into systems and making changes to the actual configuration. So this is one thing. But we might think that no one had made a change, but in some cases, configurations can conflict with patches. So there are cases where patch might remove a configuration. It is not so common, but it happens. And the third thing is related to changes to the platform's default. What does it mean? It means that if you have upgraded an operating system, for example, it might be just a minor upgrade, but definitely if you're changing the version of the operating system, you should assume that this change will reflect or create a configuration drift. You won't have the same baseline or secured configuration implemented anymore. Configuration drifts, as we understand, can happen, and we also understand that there are configuration vulnerabilities and software vulnerabilities. This table here is summarizing in a pretty simple way the difference between the two of them, and it's not just the difference; it's also how we as IT or security engineers need to deal with them. So let's take a quick look, and we're starting with the focus. If we're talking about configuration, we are looking at the system and security settings level. Unlike patching, where we're looking into the software code that has some security flaws. The typical source of recommendations or guidelines in how to avoid this type of vulnerabilities is coming from CIS benchmarks, DSS or vendors' best practices. On the other hand, when we're looking into patching, it is usually vendors that are providing the patches and hotfixes. And yes, we have databases like NVD or CISA databases that are collecting it from the vendors, so they can be easy to find. Um, what does the what is it? It is addressing with configuration. We're talking about weak configurations or insecure settings that need to be changed. While with patching, we're talking about the vulnerabilities themselves of the operating system code or component code, which means we need to patch. How we are mitigating in the level of configuration, of course, it is changing the default settings, while with patching, we actually need to upgrade or deploy the patch. How frequent is a topic where, in many cases, we will see kind of a change or a lack of understanding. The frequency of configuration changes is pretty different from patching. It's not every other Tuesday. Having said that, when there is a new benchmark or it might be a new configuration vulnerabilities, you want to be on top of it. You don't want to stay for 2 or 3 years and then realize that you need to change your baseline. You would like to adapt. My recommendations do it on a bi-yearly basis where you're reviewing your secured baselines to make sure that you're keeping up with the latest relevant configuration vulnerabilities. And we need to understand that this is not a one-time thing. Once you have hardened your system and you're now configured it in a secured way, it is something that needs to be monitored and repeated. Unlike patches, when you just deploy the patch and the hotfix and you're secured. With hardening, with configuration, if we'll not look into them and make sure that there aren't any drifts, so we'll be exposed again. The other thing is visibility and with configurations, visibility into configuration changes is something that is often missed and does not get the relevant focus that it requires, because every change to a configuration might be an exploit, but also might be reflecting a compliance issue. So we don't have many tools that are constantly observing configuration changes. This is something that usually is done one. Unlike patches where vulnerability scanners are constantly monitoring the environment for vulnerabilities. And going into the topic of, or summarizing the topic of how I see configuration versus software vulnerabilities, we need to change the way that we think about them. And just like you won't remove a patch from your system, there is no reason why you should allow a configuration drift. We need to constantly monitor them and make sure that systems, just like they remain patched, they should be remain properly configured. But why is it critical for us to eliminate a configuration drift and minimize the time to correction? There are two different reasons why it is very important that we make sure that configuration drift does not happen, and if it happens, it is corrected in a timely manner. And we can disconnect it or divide it into two. One reason is just pure cybersecurity. So these configurations can be exploited or utilized by attackers as part of an attack campaign. Usually it is relevant not for the first entrance to the organization, but if the attacker is already on a server, on a workstation, by weakening the hardening or the configuration, the security configuration, it can be actually much easier for him to either create lateral movements or just expand and extend the cyber attack. So that's from a cybersecurity perspective. That of course is from a time frame perspective. We're talking about minutes. So a configuration drift that happens can be exploited within minutes. On the other hand, we have regulatory compliance, and these days, is part of almost every regulatory standard like PCI DSS, FFIC if you are in the banking and financial sector in the US, HIPAA if you're in healthcare, you will see a section that is discussing regulatory or hardening and configuration, secure configuration is part of the regulatory framework. Here, we're not talking about minutes. We're talking that an attacker that can take advantage of a configuration drift. We're talking about the risk of non-compliancy. Okay, if your auditor is coming in every few months, quarter, half a year, and is checking to see that there is a secured baseline and it is enforced, if configuration drifts are not corrected and are not controlled, you are in risk of having compliance and audit issues. What I would like to do is deep dive into these two different reasons or two different factors that are making us or allowing us or requiring us to go and perform configuration hardening and enforce configuration baselines in a secured and safe way. So now that we understand the motivation for us to go and configure the systems correctly, but then also make sure that we don't get any drift, let's deep dive into both the cybersecurity aspect of it and the compliance aspect of it. So let's start with cybersecurity and how does the attacker is seeing misconfiguration. So first of all, we need to understand that all of these configuration vulnerabilities as we see them are all well documented online. So there's no problem to go and just get a baseline, download the CIS benchmark. This is from the attacker perspective, and basically get hundreds of different attack vectors to the operating system. Okay, so just like we know what is a secure baseline, that's also a low-hanging fruit for the attacker. And this is very important to understand and remember, because these vulnerabilities, these configuration vulnerabilities, are serving as a weak or very simple point for an attacker to take advantage of and exploit the system. And just few examples of how misconfiguration can serve the attacker. For example, the topic of disabling or reduced logging. When an attacker that get the relevant permissions of the system is removing the relevant or the configured logging of the system, SIEM solutions, any monitoring that we run on the system cannot get the relevant logins, which means he can basically do more without us seeing and observing it. Everything related to privilege escalations. If we're attaching as attackers, we're attaching topics related to user rights assignments, what a user can do locally on the system, regardless of the user permissions themselves, how the user is interacting with the system, what he's capable of doing, what type of users can do what on a given server. We are exposing the system to more activities that an attacker can do, or a malicious software can run on the target machine. And just like that, everything related to access controls. By weakening the configuration or removing secured configuration, we are actually exposing the system to additional access than what is actually needed. Well, from an attacker perspective, configuration vulnerabilities are low-hanging fruits. From an organizational perspective, they are actually pretty hard to maintain. There aren't many solutions or tools that can proactively monitor, implement, and make sure that they are properly configured on your systems. It is also a pretty silent attack path. Most SIEM solutions, most SOC and EDRs won't proactively monitor out of the box changes to configurations. So in many cases, if you are not enabling any special monitoring on your systems, it means that configurations can be changed, configurations can be exploited without you knowing. And just like it is hard to monitor them first place, also finding out that the configuration was the root cause for a cyber attack, it is something that is hard to detect, and therefore we like to call it the silent attack path into the system. So let's take a couple of configuration examples and deep dive into what they're causing by not properly being configured as the recommendation. So let's jump into a topic coming from the Red Hat world, and that's the topic of sysctl configuration. And just one of the few dozens of settings that can or should be configured as part of the sysctl configuration file. We can look into net IPv4 conf and how it should be configured. So in this case, we want to make sure that this server should not serve as a router and remove any IPv4 communication. Why is that? From a cyber risk perspective, we want to make sure that when routing is enabled, or the risk is that when source routing is enabled, someone who sends a packet can basically spoof it and abuse it as kind of a man-in-the-middle attack. So we want to make sure that we are not exposed to any network monitoring or any redirection of traffic from the control systems. So we're talking about network task boundaries and increases risk to interception or lateral movement. It means that in this case, we want to make sure that the default of IPv4 is basically 0. So there won't be accepted any source route, and therefore we're setting it to 0. And you can see that over the probably few years, we have few groups that took advantage of this attack path, either to perform man-in-the-middle attack or a network spoofing. For example, APT41, APT34, and if you go to Meteor, you'll see a handful of these type of groups that are taking advantage of this specific configuration. And this is only one configuration out of a few dozens of sysctl level configurations that we have. Let's move more into the Windows world. And one of the more known topics that over the years we've seen many attack paths or attack chains that took advantage of it is RDP. Um, and with RDP, of course, we have this actual RDP configuration on a given box, but we need to look into the session limiting. What can be done during the RDP session? And in this case, RDP session misconfiguration does not create any access point, but it can amplify what an attacker can do once you got privileges or already escalated to take over a system. And let's take the example of clipboard redirection because our ability to utilize clipboard redirection between a compromised system to the rest of the infrastructure can actually shorten the time that a malicious code can be distributed to many different endpoints, workstations, or servers. Of course, increase the blast radius, and most importantly, detection is something that is very hard to gaining visibility into what is it that can be utilized or transferred over the clipboard redirection option is something that is very hard to detect. So in this case, we're not looking into an entry point, but actually distribution point. So the configuration itself is do not allow clipboard redirection, and the cyber risk, as we said, can be just weak distribution, which is very hard to be monitored during the actual action of the attacker or malicious code, which is distributing itself over the clipboard option, which is an integral part of RDP. So what we want to do is um, limit the clipboard redirection or maybe completely remove it. So we're just not allowing any clipboard redirection. And that's the recommendation from a hardening standpoint. And as you can see, again, we have many groups, many attack campaigns that took advantage of this capability. And if it is possible to remove or enable do not allow clipboard redirection, it's very important to do so. To summarize the topic of attack campaigns and how they are interacting with configuration vulnerabilities, we've just seen two examples of a specific configuration out of hundreds, if not thousands of configurations at the operating system level that is serving and exploited out in the wild by attack campaigns. And this is the short-term risk associated with configuration vulnerabilities or configuration drifts. On the other hand, we have the midterm risk. And the midterm risk, as we see it, is associated with regulatory compliance. If you are a regulated enterprise, it might be coming from any local government regulations that you have, or industry standards such as PCI DSS, HIPAA, etc. There is a very good chance that as part of this regulation, you have a whole section discussing configuration vulnerabilities, configuration drifts, and as we call it, the way to remediate is system hardening. So let's take a couple of examples here. The first one is coming from PCI DSS. And as you can see, we have in PCI DSS requirement 2.2, and as part of it, 2.26, which is discussing the topic of system hardening, how system components should be configured. And it includes, of course, removing unnecessary service, disabling any insecure protocol, and applying secure default configurations to the systems. But it's not just that. If you then go to requirement 6.5, you will see that there is a whole section discussing the topic of change management. And when we look into change management, we are we are actually observing who should change what should be the organizational process of performing a change to the system. So in the case of PCI DSS, change management should be authorized, should be tested and controlled. If we are matching or if we are connecting requirement 6.5 to 2.2, it means that we need to first perform system hardening, but then be on top of the actual change control process of a hardened system. So the system should remain compliant, should remain constantly configured according to baselines. That's actually what it means. Another example, more for health and not payment, but same idea, the new proposed HIPAA rule. So if we're looking into section 164312C1, standard, we are talking about configuration management. And under this proposal, as stated by the law, that this proposal, a regulated entity also would be required to establish a baseline level of security for each relevant electronic information system and technology asset in its relevant electronic information systems to maintain such information systems and technology assets according to the secured baseline. What does it mean? It means that we first need a baseline. This baseline can be a secured configuration as we see this topic audited by external or internal auditors. A known industry baseline such as CIS benchmarks should be more than enough. But again, what HIPAA is stating here is that it is not just about enforcing it one or maintaining the documentation of the baseline. We need to make sure that the baseline is actually maintained, configured on our system. And this is again talking about configuration drift. So we are seeing it here two examples. One coming from PCI DSS from the payment world, the other coming from the HIPAA side from healthcare. And you can go and see it within other regulations like FDIC, FFIEC, and more state, regional, or a nation type of regulations that are stating that we need to first enforce the baseline, maintain it, and make sure that appropriate change management is being performed. So only authorized users in an authorized process can change a secured configuration. Now, making sure that secured configuration remain in force is something that, especially with large environments, can be quite challenging. It's not just that maintaining the infrastructure compliant or secured is something that requires effort from both IT and security teams. It is also the initial implementation. So what we see in many cases here at CalCom are organizations that might have few GPOs for the server environments on the Windows side or on the Linux side, just few scripts that are running, or maybe a golden image. But when you go and test and verify if the systems are properly configured according to the organizational requirements, there is quite a gap. So the initial enforcement or achieving compliance, the initial level of compliance is quite a challenge, especially due to conflict with applications or the risk of creating operational damage while we are performing the configuration changes to implement compliancy. The other topic is everything related to configuration drift. Once we've already implemented the baseline, the CIS baseline, for example, how can we make sure that over time we are not exposed to configuration drifts that can cause what we discussed today? And maintaining configuration drift requires some kind of an automated process. These two challenges of first deploying a baseline, but then maintaining it deployed is what we are doing here at CalCom. This is how we are handling it with both our solutions and expertise. And if you are in the process of implementing a baseline or you're experiencing configuration drifts and struggling with audit points related to baseline hardening, please reach out and we'll be more than happy to assist. Thank you and have a great day.